Hi, hello, I'm Kiran Kumar, physics lecturer. Today topic is effect of finite mass of the nucleus on the Bohr model of atom. Welcome to my channel, Nature of Physics and Art. Please watch my previous videos. Now, how the effect of finite mass on the nucleus in Bohr model of atom, step by step we will discuss. In the atomic spectra of hydrogen atom or hydrogen like atom, very small variation with the Bohr model of atom. Okay, this is the assumption in which the nucleus has infinite mass. What is that? The nucleus is infinite mass. That's why the nucleus is in rest position. Around the nucleus electrons are revolving. This is the nucleus, positive charge, electron is negative charge, which is revolving around the nucleus. Okay, but in fact that nucleus is not infinite massive. We are considering that is finite mass of the nucleus. What will happen? The nucleus and here electron both are revolve with common center of mass with same angular velocity. See, this is the nucleus here and that is taken as positive charge. Okay, this is the center of mass of the nucleus and the electron system. Initially, the nucleus and the electron separated by a distance small r, and from the center to the electron distance is r1. From the center to the nucleus distance is taken as r2, and here capital M is the mass of the nucleus and small m is the mass of the electron. So center of mass of the here nucleus and electron system like earth moon system. Here the nucleus moving with angular velocity omega and electron also revolving with angular velocity same angular velocity, but from center to the electron distance is r1. From the center of mass to the nucleus is r2 distance, but total distance between the nucleus and electron is r. We know very well. Okay, so step by step we will discuss the r1 distance, r2 distance, and also here centripetal force which is equal to the electrostatic force. Okay, see now initially I am considering here r1 which is equal to capital M r divided by capital M plus small m. Here r2 which is equal to small r divided by capital M plus small m. Okay, so r1 distance from center of mass to the electron, r2 distance from center of mass to the nucleus. According to the center of mass, r1 and r2 values I wrote. Okay, see, and continuation here. Here the electron is revolving around the nucleus. That's why on the electron necessary centripetal force is acting. That centripetal force is provided by electrostatic force between the nucleus and the electron. So I am going to write here Fc which is equal to Fe. Okay, see now Fc value is mv square by r which is equal to 1 by 4 pi epsilon naught q1 q2, that is here Ze into A divided by r square. Here r and this value is get cancelled. I'm not cancelling here because of V is equal to R omega I will replace. Okay, say but here velocity which is equal to R1 omega, because of here R1 is the distance from the center of mass to the electron. So m into R1 square omega square divided by R1, which is equal to 1 by 4 pi epsilon naught Z E square divided by R square. Here also we can take R1. Okay, so this and this is get cancelled. Okay, so now m into R1 omega square, which is equal to 1 by 4 pi epsilon naught Z E square by R square. But R1 value I am replacing. Okay, so that m into R1 is capital M R divided by capital M plus small m into omega square 1 by 4 pi epsilon naught Z E square divided by R square. Try to understand. Here we can write small m capital M divided by capital M small m value, that is equal to mu, that is a reduced mass. So that we can considering as constant. So that is taken as here constant. Okay, see, step by step we can discuss here, that is mu into R omega square, which is equal to 1 by 4 pi epsilon naught Z E square by R square. Okay, and from this equation here R mu into R cube, R square from RHS side to LHS side, already R is there, that's why R cube omega square, which is equal to Z E square divided by 4 pi epsilon naught. This is the equation 1 with this. And next, law of conservation of angular momentum. Based on the both equations, we will get the radius of the revolving electron or small r value. We will discuss step by step. According to the Bohr theory of quantization, the total angular momentum of the system remains constant. That is second postulate of Bohr model of atom. See, here I am considering that is L is equal to NH by 2 pi. Try to understand. Okay, so here L, which is equal to angular momentum, is Li I1 omega plus I2 omega, which is equal to NH by 2 pi. Okay, say here I1 is mr1 square omega, I2 is capital M r2 square omega, which is equal to NH by 2 pi. And here m into r1 value is m square r square by capital M plus small m whole square into omega plus capital M small m square r square divided by capital M plus small m whole square into omega, which is equal to NH by 2 pi. Try to understand. Here m capital M r square omega is common. Here capital M, here small m whole divided by capital M plus small m whole square. This square value, this is get cancelled, which is equal to NH by 2 pi. Okay, see now here small m capital M, okay, divided by capital M plus small m into r square omega, which is equal to NH by 2 pi. Okay, so this small m capital M divided by capital M plus small m represent the reduced mass. That's why mu, which is mu into r square omega, which is equal to nh by 2 pi. This is taken as equation number 2. Okay, I am doing here equation 2 square. Equation 2 square, that is mu square r to the power of 4 omega square, which is equal to n square h square divided by 4 pi square. That is taken as equation number 3. Okay, with the help of equation 3 and this is equation 1, we will get the radius. Please copy this. Now we will get the radius based on the equation 3 and equation 1. See, from equation 3 I am writing, that is mu into mu r cube omega square into r, which is equal to n square h square divided by 4 pi square. Here mu r cube omega square value replacing, that is mu into, tell me, z e square divided by 4 pi epsilon naught into r n square h square divided by 4 pi square. Try to understand. Here 4 get cancel, pi square get cancel, and r, which is equal to epsilon naught n square h square divided by, here that is pi into mu z e square. Okay, what is the difference between the radius of the Bohr model for the infinite mass? Here for the finite mass, only one difference, that is here for finite mass of the nucleus we are getting mu is the reduced mass. That value is already we know, that mu, which is equal to capital M small m divided by capital M plus small m. Okay, but in infinite mass, that is here instead of mu we can write m is the mass of the electron. That is only difference, remaining is same only. So r is equal to epsilon naught n square h square divided by pi m z e square for the infinite mass of the nucleus. For finite mass of the nucleus, r is equal to epsilon naught n square h square divided by pi mu z e square. Here mu value is given, so please copy this. Continuation. Potential energy of the system and also kinetic energy of the system. That system is finite mass of the nucleus on the Bohr model of atom. See, first potential energy, then kinetic energy. See, potential energy of system, that is Pa, which is equal to 1 by 4 pi epsilon naught z e square by r. See, here negative sign considering. Okay, so potential energy against the electrostatic force. See, here Q1 is Ze and Q2 is charge of the electron. R is the distance between the nucleus and electron. 1 by 4 pi epsilon naught is constant. See, from this equation we can write potential energy, which is equal to minus Z E square divided by 4 pi epsilon naught into R, that is potential energy minus kz e square divided by r. What is K here? 1 by 4 pi epsilon naught. Okay, next potential energy. After that we can discuss kinetic energy. Second one is kinetic energy of the system. See, for kinetic energy, Ka, which is equal to 1 by 2 I omega square plus 1 by 2 I2 omega square. Why we are considering here two values? For first one is electron, the second one is for the nucleus. Both are moving around the common center of mass. That's why I1 is the moment of inertia of the electron and I2 is the moment of inertia of the nucleus. So here kinetic energy, which is equal to 1 by 2 I1, that is small m r1 square omega square plus 1 by 2 capital M r2 square omega square. So kinetic energy, which is equal to 1 by 2 m r1 square, r1 value is capital M square r square divided by capital M plus small m whole square into omega square plus 1 by 2 capital M small m square r square divided by capital M plus small m whole square into omega square. So now kinetic energy, which is equal to 1 by 2 m capital M r square omega square is common, that is capital M and plus small m divided by capital M plus small m whole square. Here this value is get cancelled, then we got kinetic energy, which is equal to 1 by 2 capital M small m divided by capital M small m into r square omega square. So final kinetic energy, which is equal to 1 by 2 this small m capital M divided by capital M plus small m value represent mu is the reduced mass into r square omega square. This is the equation for kinetic energy. We will modify the kinetic energy and adding the potential energy and also kinetic energy, then we will get the total energy. Please copy this. And continuation equation for the kinetic energy. See, kinetic energy, which is equal to 1 by 2 mu r square omega square we got. From this relation, okay, the value is replacing in kinetic energy. Okay, see, now kinetic energy Ke, which is equal to 1 by 2 mu r cube divided by r into omega square. What happened here? What I did here, r is multiplied and divided. Okay, so then this value is replacing here. Okay, so kinetic energy, which is equal to 1 by 2, that value is z e square divided by 4 pi epsilon naught. See, okay, into 1 by r is there. This is okay. So kinetic energy, which is equal to, we can write as z e square divided by 8 pi epsilon naught into r, or we can write here kinetic energy Ke, which is equal to that is kz e square divided by 2r. See difference, kz e square by r, here kz e square by 2r, but here negative sign, but kinetic energy is positive sign. Please copy this equation, then we will discuss the total energy of the system. Now total energy of the system, that is sum of the potential energy and kinetic energy. See, so total energy Te, which is equal to potential energy plus kinetic energy, that is equal total energy E, which is equal to potential energy and kinetic energy added, we will get minus ZE square divided by 8 pi epsilon naught into R. See, here multiplying and dividing with 2, that is minus 2 ZE square divided by 8 pi epsilon naught into R, that is added. So plus minus 2 is minus. So we got here total energy E is equal to minus ZE square divided by 8 pi epsilon naught into R. So continuation we can discuss here, that is energy of the nth quantum state, that is energy of the nth quantum state, energy of nth quantum state En, which is equal to minus ZE square divided by 8 pi epsilon naught Rn. Here Rn value already we know. See, this is Rn. Replacing in this equation, that is here En, which is equal to minus ZE square divided by 8 pi epsilon naught into Rn value is, that is epsilon naught n square h square, okay, into this denominator value here I am writing in numerator, that is pi mu ZE square. Try to understand what is get cancel here, pi get cancel, okay. So then the resultant equation En, which is equal to minus mu z square e to the power of 4 divided by 8 epsilon naught square n square and h square. Try to understand, okay. So in this equation I am doing multiplying and dividing with small m, that is mass of the electron. See, small m divided by small m. So En, which is equal to minus mu into m z square e to the power of 4 divided by, okay, 8 m epsilon naught square n square h square. M is there, okay. Here mu is here only, m is there, okay. Then the resultant equation we will discuss. There is no space, that's why please copy this equation. Here mu value I will replace, that is capital M small m divided by capital M plus small m, and we will get the resultant equation. Please copy this. Try to understand here. See, I am doing this equation is modifying like this. Minus is there, m e to the power of 4 8 epsilon naught square h square, and remaining numerator value is z square and mu, and remaining denominator value is n square and m I wrote, okay. So this equation we can do based on the energy of the Bohr model of atom. Already we are doing also Bohr model of atom, but there that is the infinite mass of the nucleus and this is the finite mass of the nucleus. So En, which is equal to minus, this value is 13.6 electron volt, okay, into z square divided by n square. Mu value is capital M small m divided by, okay, capital M plus small m remaining I wrote, okay. So m get cancel here. So En, which is equal to minus 13.6 electron volt, okay, z square by n square into, that is capital M divided by capital M plus small m. Modifying the equation, En, which is equal to minus 13.6 electron volt z square by n square whole divided by, that is 1 plus small m by capital M. This is the energy of the total energy of the system, total energy of the system, okay. See, please copy this. This is system, sorry. Here already we did energy equation. Based on the energy equation, we will get the wavelength of the photon emitted from the higher energy level to lower energy level. That we will discuss step by step. Please listen to me. Now here En, which is equal to minus mz square e to the power of 4 divided by 8 epsilon naught h square into 1 by n square into, that is mu value I'm replacing, we will get 1 plus small m divided by capital M here. Already we did this in the previous equation. See, and here photon is emitted. Okay, so then we have to find the wavelength of the photon from the n2 to n1, that is energy E, which is equal to E2 minus E1. So then E, which is equal to, here continuation equation, that is mz square e to the power of 4 divided by 8 epsilon naught h square, into 1 plus small m by capital M into 1 by n1 square minus 1 by n2 square. Okay, so this E, which is equal to, we have to write continuation, please 1 second only. Okay, okay, so rearranging this equation, E is equal to h mu, that is E is equal to hc by lambda, hc by lambda, which is equal to, here mz square e to the power of 4 divided by 8 epsilon naught h square 1 plus small m by capital M into 1 by n1 square minus 1 by n2 square, and here 1 by lambda, which is equal to mz square e to the power of 4 divided by 8 epsilon naught ch cube 1 plus small m by capital M into 1 by n1 square minus 1 by n2 square. Okay, and last equation C. Okay, that is 1 by lambda, which is equal to m is the mass of the electron replacing E is the charge of the electron, and epsilon naught value, C is the velocity of light, h value replacing, we will get the value is as Rydberg constant, that is taken as r naught into z square whole divided by, here 1 plus small m divided by capital M into 1 by n1 square minus 1 by n2 square. Okay, here R naught is the Rydberg constant. Rydberg constant, that value is m e to the power of 4 divided by 8 epsilon naught ch cube. Here R naught value, which is equal to 1.097 into 10 to the power of 7 into 10 to the power of 7 per meter. So this is the value for the Rydberg constant. This is the wavelength emitted by the photon when electron jump from the higher energy level to lower energy level. Please copy this. Previous derivation, just to 2-3 steps. Okay, actually here this is epsilon naught square. There I wrote only epsilon. Very sorry, please copy this. Now one example problem. See, a positronium atom consists of an electron and a positron revolving about their common center of mass. Calculate first separation between the electron and positron in their first excited state. Okay, and second, kinetic energy of the electron in the ground state. Ground state n is equal to 1 and first excited state n is equal to 2. Okay, try to understand. We can discuss this problem step by step. Okay, so according to this question given here, positron, that is like a nucleus, and electron is a revolving. Okay, and Cm is the common center of mass. Okay, and both are separated by a distance is r. Okay, and half of the distance from the center of mass to the positron is r by 2, half of the value of r, and remaining distance also r by 2. Okay, first based on the center of mass, we will discuss the centripetal force acting on the electron. The necessary centripetal force is provided by electrostatic force between the positron and the electron. C, that is Fc, which is equal to Fe. Here the centripetal force, which is equal to the electrostatic force. Centripetal force is m r by 2 omega square, which is equal to, that is k e square divided by r square. Try to understand here. K is equal to 1 by 4 pi epsilon naught. Okay, see, then here m r omega square, which is equal to 2 k e square by r square value. Here I am writing r cube. Both side multiplying with m, then m square r cube omega square, which is equal to 2m k e square. Both side multiplied with m only. Okay, now we will discuss the, according to the law of conservation of angular momentum, total momentum of a revolving electron remains constant. That is second postulate of the Bohr model of atom, that is L is equal to nh by 2 pi. Here the distance is same between the, okay, center to the positron, center to the negative charged electron. So I am writing like this. Here I omega into 2, which is equal to nh by 2 pi. 2 is twice. Okay, so then I value is m r square by 4 omega into 2, which is equal to nh by 2 pi. Try to understand. Here we can do both side multiplying with both sides squaring, that is m square r to the power of 4 omega square divided by 4, which is equal to n square h square divided by 4 pi square. And rearranging this equation, what is that? Okay, that is here m square, okay, r cube omega square divided by 4 into r. Here r is common, this side I am writing, which is equal to n square h square divided by 4 pi square. Please try to understand. Just here r is taken common. Okay, so here this value is replacing this value. Okay, that is 2m k e square divided by 4 into r, which is equal to n square h square 4 pi square. Okay, and continuation we can write r value. Okay, so that before going to that, please copy this. Here we got relation from this equation. Continuation, here 4 get cancel, and LHS side multiplying and dividing with 2. Try to understand. Now the resultant equation, we need R value, so that R which is equal to denominator is 2 is there, and that is 2n square h square divided by, okay, so already here pi square is there, then we can write here 4, 2 to the 4 pi square m k e square. Try to understand. Okay, so R which is equal to 2 into n square h square divided by 4 pi square m into 1 by 4 pi epsilon naught e square. Here 4 get cancel, pi get cancel, and the resultant equation R which is equal to 2 into, that is epsilon naught n square h square divided by pi m, okay, z is square. Here z is equal to 1 for the proton, okay, positron, sorry, so e square. This value R is equal to into epsilon naught h square divided by pi m e square into n square. Okay, see, continuation we can write here R is equal to into this value is 0.53 angstrom into n square. Okay, just a second. Here in the first question, what is given? First excited state, that is first excited state, that is n is equal to here. So we can write here R is equal to 2 into 0.53 angstrom into 2 square. So that R which is equal to 2 to the 4 into 2 is 8, 0.53 angstrom. Then the resultant value I am writing here R which is equal to 4.232 angstrom is our answer for the given question. Okay, that is first answer only. Please copy this and try to understand the steps. Second one is kinetic energy of the system. See, for kinetic energy, Ke which is equal to 1 by 2 mv square, where V is equal to R omega but R is equal to R by 2. Try to understand. So kinetic energy which is equal to 1 by 2 m R square by 4 omega square. Okay, so then kinetic energy Ke which is equal to 1 by 2 m R square omega square divided by 4. Try to understand. Initially we did centripetal force provided by the electrostatic force, then here m R omega square, here R is R by 2, here electrostatic force, that is K E square divided by R square. Modifying this equation we will get 1 by 2 R square omega square which is equal to K E square by R. Just R square and R is replacing. Try to understand. Because of here in this equation I am replacing 1 by 2 m R square omega square which is equal to K E square by R. So kinetic energy which is equal to K E square divided by R, K E square divided by R into 1 by 4. Okay, this is the 4 here I am writing. Okay, so this is 4. Okay, so kinetic energy which is equal to here K E square divided by 4 into R, but the radius value we got from the first question, that is Ke which is equal to, okay, Ke square divided by 4 into R value is 0.53 angstrom into 2 into n square. Okay, so here K value replacing, E value replacing, and n is equal to 1. So n is equal to 1 for the ground state. Kinetic energy asking in the ground state. and continuation we can write here kinetic energy Ke, which is equal to, that is minus 13.6 electron volt divided by 4. Okay, so this value is completely K is square divided by 0.53 angstrom into 2. Here n is equal to 1. That value is minus 13.6 electron volt divided by 4 is remain same. After solving this, we will get kinetic energy which is equal to 3.4 electron volt. Please copy this. Thank you. Here kinetic energy positive only. Sorry. Please copy this.